Welcome to solverfy.
Once again, welcome to new problem. This time we're dealing with regression. So we're looking at regression, and regression is a build-up from correlation. And when you think about regression, your typical regression equation. So if you think about the regression equation, it's the same as y hat equals to beta naught plus beta 1x, where x is the independent variable. We could also call x not just the independent variable, but we could call it the explanatory variable, and then y is the response variable, and instead of calling it the response variable, we could call it the dependent variable. So there's almost a relationship between independent and dependent, and response versus explanatory variable. Beta naught is the intercept, and the intercept is the value of y when x is 0. And then, of course, beta 1 is the slope, and the slope tells us the change in y relative to the change in x. That's your regression equation, your typical scatter plot that shows the relationship between the x and the y variable is typically provided. And so we're looking at a problem where the height of a roller coaster is given in feet, and the maximum speed of the roller coaster. So we have height and speed. You could have different types of roller coasters, but this is the height, and then we also have the speed of the roller coaster. The height is in feet, and the speed is in miles per hour. So height and speed. And these are a sample of 7 randomized roller coasters. So the first thing we want to do, given the height that's in feet and the speed, maximum speed in miles per hour, we want to have a scatter plot and the regression graph. So those are the two things we're looking at. We're going to start with the regression graph, where the x-axis is the height, and this height is provided in feet. And then we also have the speed, or rather the maximum speed, and the maximum speed is given in miles per hour. So if we start at 50, we're going to have 100, and then we're going to have 150, and of course we're going to have 200, and this is in feet, and then we're going to have 250, and finally we're going to have 300. On this other side, if we start at 30, we're going to have 40. So these are increments of 10. So we're going up 10 spaces, and all these 10 spaces, we get to 90, and then we're going to get it to 100. And then the next stop is to provide different points of the scatter plot. So we have the first point. If you go back, you can see we have different points right here. We're going to have different points right here, and these are the points we're using from the graph. So the lowest point in terms of speed is 35, and this lines up with 51.8. So these are the points you're looking at. So we're going to have all the different points provided. So these are all the different points we're looking at, and so we're graphing them one at a time. Each one of these points that contribute to the graph, these are 7 points, so we have 4 points so far, and then we're going to have all these points that are provided. And then the final point is, if you go almost close to 90 and almost close to 300. So there are 2 points that we can identify that are supercritical. The first one, we had it as 35 and 51.8, and then the second one is 305 and 90. So in fact, we should push it off a little bit, so it's at 305, just some a few spots to the right. So somewhere right here, 305. So these are all our points connected to the scatter plot. And then we're going to graph the line. So when we graph it, it goes all the way like that. So we're going to graph it all the way like that. We try it again. And we're going to graph it all the way like that. So this is our equation. So y hat equals to a plus bx. So we can say y hat is the same as a is equivalent to 24.35 plus b, which is the slope, is equivalent to 0.214. So the slope is equivalent to 0.214. That's the slope. And then, of course, we're going to have x right there. So that's provided in part B. So we just completed part A. We're assuming that there's going to be a point with an additional point with a slow roller coaster. So 297 and 45 miles per hour. So 297 and 45 miles per hour. So we'll see what's going to happen in terms of the regression equation if we add an extra point. So 297, and we're going to add another extra point, 45. So once we add these 2 points, we want to see in terms of the regression equation what's going to happen. So the linear regression equation is what we're looking at. So the outcome in part C, or the second part, part B, we should have connected these two. So this should have been B and C, and then this should have been B, and then this last one should have been C. So that's what we're doing in the problem, just to make sure we have an organized system. So 297, we do have a new equation in part B. So the new equation is y hat equals to the intercept, which is 33.31, plus the slope, the new slope, which is 0.13 x, 0.13x. So this is the second equation. Just remember that we also did have the first equation right here. So the question is, if we go back to the last portion of the problem, we want to determine how the slope and the intercept change in part C. Now it's part B. So we'll say that the intercept increases. So we'll say let's write this out. The value of the intercept increases, and then let's see what happens to the slope, and the value of the slope from 0.24 decreases. Hope you enjoy the problem. Feel free to send any questions or comments, and have a wonderful day.